So in this example, the graph of y equals g of x is the image of the graph of y equals f of x. F of x is the graph in red, g of x is the graph in blue. And there's a combination of transformations. We want to write, then verify an equation for the image graph in terms of the function f. So this question is a working backwards question. Working backwards questions are tricky sometimes.
Sorry for the interruption. Any grade 12 students with the last name starting with N to Z and grade 12 students N to Z who have stairs, please go to the theater right now. That's any grade 12 students with the last name starting with N.
So if you were working forward on a question like this, what would you have done? You would have had your red graph. You would have labeled points, and you can see they've given us 2 points. They've given us the point A, 0, 8, and B, 2, -8. You would have had your equation, and on your equation you would have been able to label what your stretches, compressions, reflections, and translations would all be, and then you would have said that the point 0, 8 and 2, -8, they ended up going to -2, 0 and 0, -8. And then you would have been able to graph the blue equation. You might have even done more points than this. Now we have to work backwards. We know where the red points go and where they end up on the blue ones, but we don't know what to write above the arrows. What should I multiply x by? What should I multiply y by? How much should I move it left, right, up, or down? I don't know. And when we did this example in question 3, there was just stretches, so there was only one set of arrows. It was really easy to look at the points and figure it out. But when there's 2 sets of arrows like this, you can guess and check for a long time and maybe not find it. So in 3.3, I gave you a second method that I said we're going to use this later. This is where we're going to use it. In that second method, you remember, we first looked at horizontal distances, and we looked at the horizontal distances on our original one. So if I went from A to B, I'm starting at 0, I'm going 2 to the right, so I'm going to put a +2 for my horizontal distance between A and B. Then if I look at A prime to B prime, on my blue graph, I'm going from -2 to 0. I'm also going 2 to the right. When we look at our horizontal distances, they're not changing. There's nothing that your x values, well, technically your x values are getting multiplied by 1, but there's no stretch or compression for x. When we look at our vertical distances, from A to B. Well, A is starting at +8 and B is at -8. So to go from A to B, I would have to go down 16. So I would write that as -16. And from A prime to B prime on my blue graph, I'm at 0. I'm going down 8. That'll go to -8. Is there any multiplication that would take you from -16 to -8? You would have to multiply y by 1/2. Now that will allow us to say above these first arrows, I know that we have to multiply y by 1/2. Now I'm going to take out a different color here, and beside this horizontal and vertical distances, I'm going to write a number 1, because that's what we have to do first. okay? Because if you reread your notes later, the order when you read it is not the order that we did it, so that can be a little bit confusing when you're studying. So we did this horizontal and vertical distances first, and that allowed us, and I'm going to put a little 2 here, to write y by 1/2 there. Because I know that y has to multiply by 1/2, I can now fill in these points. Multiply my y coordinates by 1/2, my x coordinates are not going to change. So filling in these points is the third thing that we can now do. And once you have that first set of arrows done, now it's really easy to look above this last set of arrows and say, well, what has to happen? Is there something easy, horizontal translation, that would take me from 0 to -2 and 2 to 0? Yes, that would have to be 2 left. Is there an easy translation to go from 4 to 0 and -4 to -8? Yes, that has to be 4 down. So we had to do step 1 in order to figure out what our stretches and compressions were. We could then label it above our first arrow, and once that was labeled, then it was easy to find the points, and then finally the translations were easy after that. We can now do step 5, which is actually writing the equation. Okay? You could either write, okay, what is it asking us for? Write, then verify an equation for the image graph in terms of the function f. So in terms of f means the right-hand side of the equation has to have f in it. On the left-hand side, you actually have choice here. You can either write y equals, in this case, I actually prefer, because the blue graph is called g of x, we're going to write g of x equals. And then from above our arrows, how would I write that y has to be multiplied by 1/2? I'd write 1/2 in front of the function. How would I write 2 to the left? Inside the function, I would have x plus 2. How would I write 4 down? Outside the function, minus 4. So this is our equation of the image graph in terms of the function f. Okay, circle question number 9. And here we go.